Oh, okay, I think we're finally running. So my apologies for all the technology glitches. Uh, so words of wisdom, I don't have a great deal to say. You all got through the first test, the one for 0232, just fine. I really am pleased about that. Setup is and it'll be the test will open on Monday, Friday. Let me get that right here. Test will open on Friday, and then you'll have all the way up through Sunday, 11:59, and the test is an hour and a half, just like last time. The only thing particularly new to remind everybody of is under the course handouts in my math lab is this handout that has all the formula sheets, all the formulas. You are welcome to print this out beforehand and have it with you while you're taking your test. Obviously, you'll need a calculator too. That's going to be super important. But if you have those things in hand, you should be in good shape. Let me just do one thing here. I am at least to, oh, that's only doing one person. Okay. What I'm going to do is I'm going to mute everyone just while we're talking, but you should have an unmute option for yourself anytime you have a question. So just because there gets to be some feedback sometimes. So I think we're all set there. Okay, great. So whenever you have a question, just unmute yourself. It's the little microphone with the arrow, with the line through it. And be back live again. Okay, so I want to kind of let this be your call. We could look at questions from the practice test, general questions, anything you like. The one thing that we will need to be aware of with the practice test is I set it up very much like I did the actual test, which means that the questions are scrambled. So we may have to just do a little hunting to get the question that you have in mind. But we will get there. We can do it. So let me see who has a question first. Anyone who has anything that they'd like to ask or say in general, who would like to go first? Anyone have a particular question?
I have a question.
Sure. Yes. Oh, hi, Megan.
Hi. My question is it okay if we could have unlimited tries on the practice test? I find that by doing repetition, it helps me to learn it better because there seems to be quite a few formulas. Having trouble trying to navigate it and decide which formula goes with which.
Okay. Yes, it should be set up that you can have unlimited tries. Let me do just a quick look back here just to see. It should be set up. I think I have it set up where you can work it over and over and over and over again, no matter how many times. Is it not letting you do that?
No, it's just showing me like the questions that I got wrong and telling me what the answer was. It's not giving me a chance to like redo it.
Okay. What I think you have to do is go back to the assignment menu, like you're starting from scratch,
Okay.
and then uh, hit it again. So I think you have to actually close out of the test and then restart it.
Okay.
Try that. If that's not working, let me know. It should, and I'll check the setting on it too to make sure I've got the setting right. But I believe I do.
Okay. I'm looking it up now.
Tell you what, I'm going to try to do the same thing. Just let me see what I've got. Yeah, I don't have a limit on the number of attempts.
Okay. Um
Yeah, at least from my end, it looks like you've got an infinite number of tries on it.
Okay. Yes, I see it. Thank you.
Is that working?
Yes, sir.
Okay, good, 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 good. Yes, and I think you also, the point you made is exactly right. The trickiest thing on this is figuring out which formula goes with which one. And that is kind of where I thought we probably would be needing to spend our time, kind of talking about of all these formulas here, which ones are appropriate. I can give you some general things to watch for that might help in general, and then we can look at specifics if you like. So what probably the one that's most obvious is going to be the loan payment formula, because they're going to tell you that there's a loan and you owe some money and how much do you owe. So the loan payment one probably will not be mysterious at all. They'll be talking about a loan, they'll be asking for the payment. You'll use that formula, this one down here on the bottom. Where people get most confused, I find, is in trying to decide whether the question involves compound interest or whether it involves an annuity. And the thing you want to watch for there is how many deposits are there. If the scenario is that you put in money one time and you let it sit there, you never add any more, just one deposit, then you're looking at the basic compound interest formula. But if you're looking at putting money in periodically, like once a month, once a year, twice a year, something like that, then you're going to be using the value of an annuity. And often the word, when you're talking about an annuity, it'll use the word it'll describe that the interest is compounded. And that often leads people to think, oh, I see the word compounded, so this must be a compound interest problem. But what you have to look at is the deposits or the withdrawals, whichever way that's going. Usually deposits. If it's once a month, then you're looking at an annuity. If it's one time at the beginning and then you sit there and let it go, then that's compound interest. The simple interest formulas, there, what you look for is if you look through the problem and there's no mention of the word compounding at all, they don't compound anything. It may come out and say simple interest, but if there's no mention of compound interest, then that definitely means you're looking at simple interest. So that might be just a couple of clues that help out just to begin with. While we're looking and while y'all are thinking about what you might like to ask, let me look at this question that's on the screen right now and see if we can figure out what formula we need and what we ought to do here. So let's take a look at this and see if that little thought process that I described is of any use to you. So how much should you deposit at the end of each month? I hope y'all can see that. I wonder if I can make it a little bigger. It doesn't make the print any bigger. How much should you deposit at the end of each month into an investment account that pays 9% compounded monthly to have $5 million when you retire in 43 years? How much of the $5 million comes from interest? This is a good classic problem. As you look at that, which one of these formulas do you think is the right one? Anyone who wants to can unmute themselves and tell me which formula you think we're looking at here. Anybody want to give it a shot?
I'm gonna go with annuity.
Good, good. That is correct. That is correct. The reason that's correct is this idea right in here that you're making a deposit each month. So because you're making a deposit every month, you're looking at an annuity. So that's actually the biggest hurdle, is to recognize you got the right formula. It's going to be this one. And let me do a little writing in here and see if we can figure out what they've given us and then how we might plug that into the calculator to figure out what the answer is. So they talk about how much should you deposit at the end of each month. That's a question there. So there's something unknown. An investment account that pays 9% in all the variables in that formula. What does the which one is the 9%? Is that A, R, N, P? What's the 9%?
The R.
The R, perfect. And we have to convert it to a decimal. So the 9% will become 0.09. Excellent. Good. $5 million when you retire is the next number in there. So among all these letters here, which one is the 5 million? Is it the P, the A?
That'll be the P, I assume. I think.
P stands for payments.
It'll be the A.
The A, yes. That's what you're aiming for in the future. That's what you hope to have at some point in the future. So the A is what they're giving you with the 5 million. Good. When you retire in 43 years, see how I'm just kind of paging through this to get the right thing. What is the 43 years? What value is that?
Isn't it the T? The little.
That's the T. That's the T. That's the T. What haven't we talked about so far? What don't we have listed here?
Time.
We don't have N. Okay. What does the N stand for? Yes. So it's the N is particularly the number of compounding periods per year. And we are making deposits monthly. So monthly means 12 times a year. The N would be 12. If we were making deposits quarterly, then N would be 4. If it was daily, then N would be 360. Remember that weird thing that a year is 360 days. So that will semi-annually is 2, annually is 1. In this case, so we have a value we don't know, and that's the P. Yeah, that's the P. And let's see if that matches. The question is, how much should you deposit at the end of each month into an investment? So how much that it's asking, what is the payment? So we are looking for the payment based on all this. So is that thought process making sense so far as just how you would analyze the question? So far, so good? Okay. Here's where we would need to use the calculator. I'm going to get this guy out of the way for a second. Hopefully.
I got a question. Yeah.
Sure, yeah.
The only question I have is for the rounding. Is like when you do all that and you get your answer, I know that's a big detrimental according to math classes because if you mess up one number, you miss the whole question. So I just want to make sure how you do that effectively, the whole rounding thing.
Okay. We'll talk about that when we do this one. And I'm going to give you just sort of something in general to put your mind at ease too. In this particular chapter, the rounding sometimes does come up to be an issue when I'm doing the grading. Watch really super carefully to see if the question tells you how to round things. Yes. Look at this very carefully. In the blue right here, round up to the nearest dollar. Okay, so I'm going to get a number on my calculator that's going to be in dollars and cents, but they want to round it and they want to round it up. Now, when I'm grading, I'm going to look through your papers, and if the answer is supposed to be, I don't know, $412 and that's it rounded to the dollar, and you wrote $411.85 because you forgot to round it, I'm going to be looking for that, and I'll give you credit for that. So don't worry too much. But the reason that they're actually going to be saying things in a lot of these questions like round to the nearest dollar is because there is room for round off discrepancy depending on how much you use the memory of the calculator versus how much you write things down, or even from one brand of calculator to another. It could be as much as a cent or so. And so if you round off to the dollar, that mostly should disappear. Let me show you how that would work here, but basically don't worry about that too much. If you see you miss a question and your answer is like super close, I'm going to be taking a look at it. You're welcome to send me an email and to say, hey, would you especially look at question so-and-so, but I'm going to do that anyway. Does that put your mind at ease a little bit?
Oh, so you're going to be on grading it?
Yeah, it will. What happens is the computer will automatically grade it. The program will automatically grade it, but I can go back through it. And if I see that it's made any discrepancies in grading, then I can change it manually.
Okay.
So that will fix any little goofy thing like that.
All right. Thank you.
You bet. So let's talk about how to actually enter this into the calculator. I've got too many windows. Let me close that one and close that one. And just look here. So I've got my calculator up. And looking over here on the left, I see all the values that I have. And I notice that what I don't have is the P. So what I can do is calculate everything else on the right side of that equation besides the P. And my answer, what will happen is that I'll have A equal P times some number. So I'm going to do everything that I see basically in the parentheses on the right, both on the top and the bottom, in my calculator. Now, there actually are different shapes of parentheses in the calculator, but you don't really need them. Just remember that if you've got a square one and a round one, you've got to do 2 parentheses. So I'm going to say open parentheses, open parentheses. That gets these 2 parentheses here. 1 plus R 0.09 divided by N. That close off the first parentheses. I'm so used to pointing at things when we're in class. You can't see me pointing at my screen though. That doesn't do any good. So now we got to raise that to a power. The caret gets you into the power. If you have a fairly new graphing calculator, the cursor will go up into an exponent. If you have an older one, it'll just show you this little caret symbol, and you have to use parentheses. I just think that when you're in an exponent, just always put parentheses around everything in the exponent. It's just a good practice. N times T, N is 12, T is 43. Then you have to get out of the exponent. You do that by this little right arrow that's in the wheel, -1, and then that finally finishes the numerator, and you have to close off the entire numerator. Okay, so that's everything on the top. Then to get everything in the bottom, you do a division, and again, put everything in parentheses, but it's much simpler down here. It's R divided by N. And you can hit enter. And where we're at right now, if I can go back over here, is we're at the point where we know what A is. We don't know what P is, but all the other stuff on that side of the equation is 6167.34. Okay. So far, so good. Now, you can write down this number And the more decimal places you use, the more accurate you're going to be. But by far the easier thing to do is to store this into the memory and click the STO arrow button for store and store it as X. Just right there. And that will take the number on that you figured out on the right and store it into the memory. You don't have to copy it down, write it down. And then when you look at your equation over here, where we're at right now, to get the P, it's just P times a number. So you would divide both sides by that number. In other words, you take the 5 million, there's 5 million, divided by that 6167.34, but you don't have to write it down because it's stored as X. So all you have to do is hit the X, and it knows that number now, and hit enter, and this is the answer that you would get. How's that look so far? Does that look all right? Everyone okay with that? Okay. Now, in writing the answer, generally speaking, when we look at something mathematically, we round to the nearest cent. But because that instruction said round up to the nearest dollar, what you would say for your payment is $811. Okay. A bank would never do that. It would tell you more exactly. But even a bank would probably say, you know what, if you give us $810.72, you're going to fall just a tiny bit short. So give us $810.73 and you'll go slightly over, and that will be better for you. They do this on loan payments too, and then they refund the last little bit to you at the very end. But for the purposes of our book, this way, if your calculator gave you $810.75, it wouldn't matter. We're rounding up no matter what. And it did say round up to the nearest dollar. So let's just say pretend that you did this question and the answer turned out to be $810.14. Because they're saying round up, you would still say $811. Even though the rounding rules usually would say make it 810, rounding up means go up to 811. Is that good? Oh, you know what? I just realized there's more to this question. Let me find it. So the answer here is going to be 811. I'll put that right there. Make it happy. The question that follows that is really important. Because there's not really a formula for it. It's something you think through. How much of the $5 million comes from interest? Now, there's no formula for that, but the way you think about this is you've been putting in $811 per month, 12 months a year, times 43 years, 8 times 12 times 43. This is your contribution, what you have actually paid into this amount. So if I get my calculator out, and it did say use whatever you got in A, so we're going to use this rounded off 811 times 12 times 43. So your contribution, what you actually contributed, was 811 times 12 times 3. That's $418,000, $476. Sorry, get it right. $418,476. That's what you actually put in. Does that make sense so far? Now, you ended up with $5 million. That means that the interest is everything in the difference between 5 million and 418,476. Everything else is interest. It's going to be an enormous amount. 5 million, zeros there. That's 500,000. 5 million. 5 million there. Yep. minus 418,476. All of that, all of this is the interest you earned. It's really pretty phenomenal. Of course, part of that is that's an interest rate you probably would never get, but, but that's what you would put in this answer here. This would be 4,500,000. Oh, it's not listening to me. 4,581,524. All right. That actually was a great question to come up first because I think it talked through a lot of the issues that we have, both what did this do up here? Somehow this changed my answer. I don't know how it did that. That was supposed to just be 811. What do you think? What other kinds of questions would you like to ask? Either general ones like the round off or specific ones, anything that you have. Just gonna clean that up.
Yeah, I have a question. It's just a small question.
Sure, go right ahead.
When it comes to putting all of them in a calculator, you were able to put almost a whole formula in it, right? You don't have to do it by parts.
Yes. Yes. Right. Exactly right. Your machine can do virtually all the thinking for you. And the more you let it do it, the better off you are actually, because every time you just do just a part of the question and say, write that number down, you're going to be introducing some small amount of round off. And the more steps you have, the more that round off will accelerate. And even with the rule that they have about rounding off to the nearest dollar, you could potentially end up $2 or $3 out of whack. So the more you can let the calculator do, the happier you're going to be.
Okay.
And even if you don't have a TI graphing calculator, if it has parentheses features on it, you should still be able to do basically what we're doing.
I mean, I mainly used the Wabbit calculator, and I just used the software to get the silver version of the calculator. But I mainly use my phone for it now, since we cannot use the calculator on the computer for it.
Right. Yeah. Yeah. If you have an iPhone, which is all I have, so I don't really know what the other guys look like, but the iPhone calculator has parentheses and has exponents. So you should be able to enter this exactly the way we're talking about. It's just instead of the little caret thing, you're going to use the X to the Y button. And I think the Android phones have a calculator that does just as much. Definitely practice with it between now and Friday and make sure you're getting the right answers. And then let me know if you're not.
You can also get the if you have Android, there's like an app that is basically the TI graphing calculator. So that's what I've been using, because for some reason my graphing calculator won't let me put in the brackets. I just get like an error message. So I've been using the TI graphing app on my phone.
Oh, good to know. Good to know. Was that free or did it cost a lot?
It was free.
Yay. Okay. Good. Good. That would be fine. That'd be fine. I bet if they've got it for Android, they probably have it for Apple too. And then
Yeah, Apple is really different from that one. Like, for example, there's a third-party one that you can use on your computer, but if you want the graphing calculator, you're gonna have to ask the Texas Institute to give you a software version of the one that you have, so you can plug it into the software, which is just a free. All you have to do is just send an email. That's it.
okay. Okay. Great, great. Good. And I think you should be able to probably just do a search on TI graphing calculator. And I think I heard they were saying they're making a lot of their software free right now.
Yeah.
It's a lot to teachers and students, just because everyone, is such in a weird position. Great. Well, while we're at it, let's take a look at this question, because this is one that comes from the first section of the book before we really first section of chapter 8 rather, before we first started looking at all these different formulas, is just when we were talking about the concept of interest of percent in general. And it's an easy question, but just to make sure we know how this goes, let me take a look at this one real fast. And this is a nice application. So you've got a bar graph, not unlike what you're now seeing in chapter 12. The bar graph shows that the life expectancy, the number of years newborns are expected to live in a particular region, has increased dramatically since ancient times. Find the percent increase in average life expectancy of the region from the Stone Age to 2016. Percent increase. And I think the main point that I want to make with this one is anytime that they're asking for a percent increase, it's always the change relative to the original value. So if you look at the Stone Age, when people, and this may be hard to read, in the Stone Age, people had a life expectancy of 23 years. That really sucks. Now it's 71 years. They want to talk about the change in life expectancy. So what you would be doing is you would be looking at the difference of the two. We've gone from 23 to 71. And a percent change is always figured relative to the original value, whether you're talking about raising a price on a dress or adding taxes or even changes in ages. So it's 71 minus 23 over 23. It's the change relative to the original value. So on the calculator, it looks like this. Again, with the parentheses, 71 minus 23, close parentheses, divide by 23. And they want this, let's think about what this is as a percentage. We got 2.08 more stuff. I'll just put down a bunch of it. 8, 6, 9, 5, 6, and some more. Yeah. So does that mean that the percent increase is 2.08%? Is that a 2.08% increase? Give me a second to think that over. Remember, this is coming out as a decimal. It has to be converted to a percent. So that means the decimal place has to slide 2 places to the right. So this isn't 2.08%, it's 208%. Putting in a few decimal places, 208.6956%, which is huge. And because they want the answer rounded to the nearest integer, you convert to the percent first, and then round that off to the nearest integer, and that would be 209. So 209%. Does that look all right?
Makes better sense now.
Okay, good. Good. I'm glad. I'm glad. Very good. Very good. Great. Great. I'm just going to page through and see if this is maybe worth talking about too. I want to talk through what you think the correct formula is on this one. And then if we want to, we'll work it. If we think we're okay, we don't need to. The principal P, oh, there's some cool stuff in here. The principal P is borrowed at a simple interest rate for a period of time T. Find the loan's future value A on the or the total amount of time due, or the total amount due at time T. Now, which formula and why? Anyone want to take a shot at that?
Would be the first one, simple interest.
Absolutely. And how do you know that?
It says simple interest on the question.
Simple interest. That's the deal. The word simple interest is right in there. So we're talking about simple interest. That's as easy as it is. Notice that we're given the P, the R, and the T, and we're looking for the future value A. So they pretty much flat out tell us what we want. We're looking for A. We don't know what that is. P is the principal, the amount you borrowed. That's the $4,000. R is the interest rate. What was the interest rate? Oh yeah, 6.5%. Remember to slide the decimal 2 places over, so it's 0.065 for R. And I'm going to ask you to tell me true or false. T equals 8. True or false? There's a trick here.
False.
False. Right. What's wrong with that?
It's 8 months, so it has to be divided by 12.
Yes, because time is always in years. Time always has to be in years. Exactly right. Exactly right. So if I want to enter this into the calculator, again, I'm going to kind of let the calculator think about everything. I'm lazy. I don't want to do any work. Enter it just the way it looks. We're looking for the A, so everything we have is over on the right side. 4,000, open parentheses, 1 plus R times, and the T is 8 over 12. We can enter it just like that, 8 over 12. The calculator understands all the order of operations issues, so you enter it just the way it looks, and you will get the answer. And then let's see what they said about rounding on this one. Do not round until the final answer, then round to the nearest cent. So this one, watch for this blue information right here, right below the answer. That's going to always tell you how to round it. And this time they want us to round it to the cent. Like that. So it'll always, it looks like they're not always consistent. Just read real carefully what they want. Is that good? I don't think we're going to have time to go through all 22 of these, but what we might do is talk about what formula to use, and then if you want to see the details, we'll go through it. But I bet to the large degree, if we just make sure we understand which formula we're using, we're going to be okay. Which formula do you think for this one? Is there a giveaway? If I can highlight here. Oh. Y'all see that?
The simple interest again?
It's simple interest. Yeah, these are scrambled. So just by chance, you've got two simple interest problems right next to each other. Because it says simple interest, we're talking about simple interest. Loans are rarely given based on simple interest. Basically, the only loans that are ever given on simple interest are really short-term loans. Frankly, this is a little bit longer than would be realistic for a simple interest loan. they would almost definitely want compound interest. But for a time less than a year, often loans are simple interest. Is that okay? Y'all need to see any more with that one, or is that? I'm going to kind of go with identify the formula, and if we feel good about that, we'll go on. Okay. I'm going to take that as a yes. It's so hard not to be able to see your faces. I can see some of you, but not all of you. Oh, look at this one. They flat out give you the formula. Isn't that tacky? Well, I think we know which formula we need to use here, right? Suppose you decide to buy a car, including it costs this much. You save $6,000 for a down payment, and you can get a 5-year loan at 7.89%. Use this formula, which you can see is the same as this one down here. Exact same formula to find the monthly payment and the total interest. Let me see if there's anything of importance here. Maybe let's at least identify what all the letters stand for. And then if you want to see more of it, we can. Just tell me. In the loan payment formula, P represents the amount that you borrow. It stands for principal. It's the amount you borrow. Did you borrow $25,635? Is that the principal?
Nope.
No. Why not?
Because you saved 8,000 or 6,000.
6,000. Yeah. I know it's kind of this print small, hard to read there. So your principal is going to be 20. It'll be easier to see here. $25,635 minus the down payment that you made, which is $6,000. So your principal, what you actually borrow, is really $19,635. Good. Okay, they try to be a little tricky here and there. I've lost my cursor. Where's my cursor? There it is. Okay. Let's see. Do we know what R is? Yeah, I think so. It's 7.89%, so that's 0.0789. N. Can y'all see that well enough to tell me what N is? N represents the number of compounding periods and payments in a year. So how do we know? Yeah, go ahead.
12.
Yeah, and we know that because it's monthly. Okay, monthly payments, so N is 12. Yay. T.
5 years.
5 years. That's the number of years. And from this, you're going to figure out the payment, the PMT. Do you want to look through you want me to do this on the calculator, or are y'all okay with it from here? What do you think? I can do it either way. Any votes for seeing it on the calculator?
I think we're good.
Okay, good. I'll make one little suggestion. If you notice really carefully, there's a small, tiny difference between the way I wrote the formula and the way they wrote the formula. Notice I've got parentheses around the denominator. That is a good idea. When you get to entering the denominator, the whole denominator needs to be in parentheses. So even though they give you the formula here, use my formula. Not to say that I'm like any super great guy or anything, but those parentheses, putting parentheses around the denominator will make the difference between the right or the wrong answer. And again, notice that the rounding rules change. So this time they want it rounded to the nearest cent. Go figure. again, I'll look through, and if the answer is something in 37 cents and you said 38 cents, I'm going to give you credit for that. I just have to go back and manually change it. Okay, let's see. Can you at least tell me what the formula is for this one? The principal represents an amount of money deposited into a savings account. Find how much money there will be in the account after the given number of years. There's a principal, a rate, a compounding period, and a time. What do you think? I think it's going to be one of these two, either this one or this one. What do you think?
I agree. That one.
This one here?
Yes.
Anyone else want to chime in on that? I can make you vote. So let's talk about this formula right here. In an annuity, the whole idea of an annuity is you're making a periodic payment. So you're putting in some money periodically, maybe once a month, once a year, once a quarter, once a something or other, versus this formula where you have an amount that you put in and you just leave it and you never add any more. Which seems to be the closest match to this?
So the compound interest would be a perfect match, wouldn't it?
It would. It's this one. It's this one.
The
Because
one-time deposit, right?
yeah, one-time deposit. One-time deposit. You're making one deposit of your principal at the beginning. You're not putting things in every month or every year or every whatever. So this is actually compound interest, not an annuity. An annuity, they would have to say you deposit $7,500 every year, say. Does that make sense? That's the kind of thing that I predicted might be the biggest sticking point in the whole chapter, is just deciding between those two. Okay, let's just take a look and see which formulas. This is kind of in a word problem. Suppose you're in a bachelor's degree now and you're teaching high school. The school district offers the opportunity to take a year off to earn a master's degree. To achieve this goal, you deposit $1,000 at the end of each year in an annuity that pays 5.5% compounded annually. Which formula? This one, or this one, or one of the others?
Wouldn't it be the 8.5 value of an annuity?
Yeah, you're exactly right, and and they kind of give it away because look at the word that's right in here, annuity. but the principle is the idea is you're putting in some money every year, so that makes it an annuity. Exactly right. Is that making sense? Are you getting the hang of that?
So.
Okay, good. I hope so. I think this one is just a straight percent question. The circle graph shows a breakdown of spending for the average household using 365 days worked as a basis of comparison. What percentage of work time does the average household spend paying for housing and housing operation? So you sometimes see this, it's kind of odd, but they figure out the number of days that you have to spend a year to earn enough money to pay for some sector of your life. In this case, 52 days that you work out of the year are just to pay your medical insurance. Here, for housing and household operation, you're spending 66 days of your work year. Oh, I gotta get the calculator out. 66 days of your work year. What percentage of that? Actually, it's just 366 divided by 365. And 18.08 would be 18.0822%. So if they want this rounded to one decimal place, we'd have to say 18.1. You convert to a percent first, and then you round to one decimal place. Good. Which formula for this one? In case it's hard to read, it says a passbook savings account has a rate of 6%. Find the effective annual yield if the interest is compounded daily. Assume 360 days in a year. Which formula does that go with?
The effective annual yield.
There you go. There you go. We haven't even used this one yet, but you just plug into that one right there. They're asking for effective annual yield. There's a special formula just for that. And the only variables that matter are the R and the N. The R would be 0.06 and the N daily 360, and then you plug it in and you go. And what that will give you is the simple interest rate that would earn you the same amount of money as 6% compounded daily. That gives you a comparison. Okay, another loan payment, and they give you the formula. I don't mind that because I'm giving you the formulas anyway. What do you think about this one? The principal P is borrowed at a simple interest rate. Guess what? We're talking about simple interest. And this time you're only talking about P, R, and T. You're given P, R, and T, and you're asked how much will you have to pay. Find the interest owed. So you're going to have to look at just this one. You're only looking at interest. The first one. Equal PRT. So they're not looking at the amount that you're going to owe, but the interest that you're going to owe. So the answer here would be P times R. What's R again? Oh yeah, there it is. 0.06 times T. And T is in days because there's 360 days in a year. You'd have to say 150 over 360 to convert that to years. And the answer is $262.50. I'm going to pause here for just a second. I had advertised this meeting for an hour, and it's about been an hour. If anyone has other plans, I don't want you to feel obligated to stay. Do you want to go a little bit longer, or do you feel like we've got enough done? I can stay if you feel like we should look at a few more, or if you have some other questions. What do you think?
I think we're good.
Think you're good? Is everyone okay with that? Maybe we've kind of given you, there's just going to be more examples, and I think we've hit all the major kinds. There's just going to be a few more of them.
Yeah, I think we've hit what we needed, like some of the stuff that we needed, I believe.
Okay, good, good. Any general questions before we go?
The test starts at exactly 12 a.m. Friday, right?
Yes. So if you want to get up super early or stay up late and take it right then, you can. You get a night.
I have work.
Yeah.
I worked the other day, so I gotta stay up.
Okay. Hey, there you go. I know everyone's work schedule is all topsy-turvy now. So yeah, you have a 90-minute window anytime beginning at at 12 a.m. Friday and ending 11:59 on Sunday. And I don't know whether you'll really need all 90 minutes, but make sure you leave yourself that much time just so you don't feel rushed. So, well, good. So has this been helpful?
Yes, sir.
Definitely.
Really helpful.
Okay,
Yes.
great. If it's been good, then I think we'll do this again before the next round of tests. Just have a time where if you can come, please do so. And I did record this, so anyone who couldn't make it can see it. It takes the system a full day to post this, so it won't be visible till tomorrow. But if you want to go back and watch again, it'll be posted, and I'll let you know when it's up. And if you have other questions, email me anytime. I'm really happy to help. And
Test we have left after this one?
so after this one, we have one more test in both classes. There's a final exam for Math 0232, and it's not a comprehensive final. It just covers Chapter 7, which was about functions and equations, and Chapter 12 on statistics, which you're looking at the moment. So that one is Math 0232. And then on Math 1332 side, there's also one more test, and it's going to be on Chapter 11. So they're not comprehensive finals, they're just regular chapter tests. And both of those are scheduled for the final week of class, which I know is vague because I can't remember what the date on that is. Let me see if I can remember.
21st through the 23rd.
Yeah, you got it. Yeah, I've got it set up for, you know what, I'm going to make a change on this. Originally, they told me that I was going to have your grades in Sunday morning, the 24th, which is why this is Thursday through Saturday instead of Friday through Sunday. I'm going to actually extend this so you can work on it Thursday through Sunday.
Oh, perfect.
That will give you a little bit more time because you probably have finals in all your classes that week. And I don't have to turn in grades now until Tuesday, so it doesn't matter to me. I can give you some more time on that. So this will change to Thursday through Sunday, give you a 4-day window. So those are your two tests that are coming up. They're both at the same time, which is kind of crappy, but that's the way final exams kind of work. But they are both just chapter tests. They're not comprehensive. Okay, well, it's been really good to see and hear from all of you. This has not been as much fun as meeting face to face, but I am really glad you guys are persisting and hanging in there. And best of wishes on this week's test. And good luck. I'll talk to you again soon.
Have a good day, Professor. Thanks.
All right, you all take care. Take care. Bye-bye.